We will now proceed with the discussion of Chapter 10, Topic 10.4, Statistical Inferences about two population proportions. Statistical inference is a process of using probability concept to deal with uncertainty in decision-making. It refers to the process of selecting and using a sample to draw inference or conclusion about population from which a sample is drawn. This is the Z formula for the difference in two population proportions. This symbol is a sample proportion. This is the sample size. This is the p-value or the probability of success. And this is the probability of failure. Therefore, in this formula, sample proportion 1 is a proportion from sample 1. Sample proportion 2 is a proportion from sample 2. Sample size 1 is the size of sample 1. Sample size 2 is the size of sample 2. P-value 1 is the proportion from population 1. P-value 2 is the proportion from population 2. And this is a probability of failure 1, and this is a probability of failure 2. The previous formula requires knowing the population proportions. Since the population proportions are generally unknown, an estimate of the standard deviations of the two population proportions was used, where, in this case, this formula was applied. To show the formula in an example, a group of researchers attempted to determine whether there was a difference in the proportion of consumers and the proportion of CEOs who believe that fear of getting caught or losing one's job is a strong influence of ethical behavior. In their study, they found that 57% of consumers said that fear of getting caught or losing one's job was a strong influence on ethical behavior, but only 50% of the CEOs felt the same way. Data were determined from a sample of 755 consumers and 616 CEOs. Does this result provide enough evidence to declare that a significantly higher proportion of consumers than of CEOs believe fear of getting caught or losing one's job is a strong influence on ethical behavior? Let us now digest the example in a step-by-step process. Step 1. Let us determine the null hypothesis and the alternative hypothesis. Step 2. With large sample sizes and unknown population proportions, the previous z-test is appropriate. Step 3. Let A, or the significance level, be equal to 0.10. Step 4. For a one-tailed test, the critical z-value for an A level of 0.10 is 1.28. Step 5. Gather data. Step 6. With all the available figures that we have, like the population size of the consumers, the population size of the CEOs, the result of the surveys, and plugging in those data into the formula, we can now make the calculation. And from there, we can identify the rejection region. Step 7. Because this test statistic z is equal to 2.59 is greater than the critical value of z 1.28, reject the null hypothesis. Using the p-value method for z 2.59, the p-value is 0.0048. Since this p-value is less than a is equal to 0.10, reject the null hypothesis. And from there, we can make a conclusion that a significantly higher proportion of consumers than that of CEOs believe fear of getting caught or losing one's job is a strong influence on ethical behavior. Let us see another example of checking confidence interval to estimate proportion of population. Suppose that, in an attempt to target its clientele, managers of a supermarket chain want to determine the difference between the proportion of morning shoppers who are men and the proportion of after 5 p.m. shoppers who are men. Over a period of 2 weeks, the chain's researchers conduct a systematic random sample survey of 400 morning shoppers, which reveals that 352 are women and 48 are men. During this same period, A systematic random sample of 480 after 5 p.m. shoppers reveals that 293 are women and 187 are men. We should be able to construct a 98% confidence interval to estimate the difference in the population proportions of men. Let us now gather the data. We have the number of morning shoppers and the afternoon shoppers, the population size, and the number of men and women for both data sample. We can now supply the given values into the formula. In here, we can see that there is a 98% level of confidence that the difference in the population proportions is between distribution 0.334 and 0.206. You can also use computer to analyze the difference in two proportions. Minitab has a capability of testing hypotheses or constructing confidence intervals about the difference in two proportions. Let us now talk about testing hypotheses about two population variances. Difference in variances is used as a measure of relative risk, like in finance, or comparison between processes, like in manufacturing. Here is the F-test for two population variances. Please note that the ratio of two sample variances follows an F distribution, and the population must be normally distributed. Suppose a machine produces metal sheets that are specified to be 22 millimeters thick. Because of the machine, the operator, the raw material, the manufacturing environment, and the other factors, there is variability in the thickness. Operators are concerned about the consistency of two machines. To test consistency, they randomly sampled 10 sheets produced by machine 1 and 12 sheets produced by machine 2. They assumed that sheet thickness is normally distributed in the population. We will now test to determine whether the variance from each sample comes from the same population variance or from different population variances. To test the hypothesis about two population variances, Step 1. Determine the null hypothesis and the alternative hypothesis. Step 2. Since the population is normally distributed, the F-test for the ratio of the variances can be used. Step 3. Let A, or the significance level, be equal to 0.05. Because we are conducting a two-tailed test, the significance level will be 0.